Okay, 2016 AIME 1, question 7. And this one I like a whole lot more than question 6. So we have integers a and b and this complex number. And we want to find the number of ordered pairs of integers a and b such that this complex number is a real number. And there's one of two ways this can happen. The first way is the easy way. So I have what looks like it should be the real part, and what looks like it should be the imaginary part. And so if I can make this part 0, then it'll just be real. And to make this 0, I want to make a absolute value of a plus b equals 0. Now, absolute value being 0 just means I want to try to find where a plus b equals 0. But there's an additional problem here, and that is we're dividing both sides by ab plus 100. So in order to make this a real number, in order to make this defined, ab plus 100 cannot equal 0. So I know that ab plus 100 cannot equal 0. And so based on this, I'm just going to go ahead and say, okay, well, let's figure out what a is. So a would be negative b. And so in here, this is the same as saying negative b squared plus 100 cannot equal 0, or b squared cannot equal 100. Okay. Second issue. If I'm considering this as the real part, then I know that this part right here has to be positive. So we already said that a is equal to negative b. So we know that if ab plus 2016 has to be positive, because if it or sorry, positive or 0, could be 0. If it is negative, then we'll get an imaginary number here, and there's something that'll work, but those are very few cases, and we'll deal with that next. So that means we need to figure out, so a is negative b, so this is negative b squared plus 2016 is greater than or equal to 0, and that means b squared has to be less than or equal to 2016. Now, this is something I don't know if I said it earlier. It's always worth your while, or a lot of times worth your while to, for the year, know how to factor the year, and know things like, in this case, 44 squared. I'll do it up here. 44 squared. 44 times 44. 6 carry the 1. 6 plus 1, so 176. And then in here, 176. So that gives me, let's see, did I do that correctly? So in here I have a 6, 3, carry the 1, so 1936. Whereas 45 squared gives me 5, carry the 2, 22, 0, 225. And this gives me something that is too big. Did I mess that up? That looks alright. Okay, so in here, what's worth knowing is that 44 squared is the biggest, or 44 is the biggest thing that when squared is still less than this. So I know that b is somewhere in 44, sorry, negative 44 up to 44. And really, I'm only considering integers, so negative 44, negative 43, all the way up to 44. And there are 89 of these. Okay, you could do 44, minus negative 44 plus 1, because you're counting the negative 44. So just case in point, if I'm going from 0 to 10, there are 11 numbers. If I'm going from negative 44 to 44, there are 89 numbers. I have this restriction here that says b squared cannot equal 100, which means that b cannot be plus or minus 10. So 89, we take away the 2 for this, gives me 87 numbers here. And now comes the fun part. So we have all this mess, but what if this wasn't the real part? What if this here were negative and I used it to cancel out the I? So here's what happens here. If this is negative, so I want AB plus 2016. I want that to be the opposite of the absolute value of A plus B. So this case is what makes this 0, the left side. This case is going to make this have some I, and the i's will cancel. So in here, now this gives me two possibilities, but with the plus or minus from the absolute value and the negative sign here, I do end up with AB plus B, AB plus 2016 equals A plus B. And now, here's the way that I went through and solved it. So I rewrote this as A minus AB plus B equals 2016. And I factored out, let me see, I ended up factoring out an A. So I got A times 1 minus B. So I'm basically trying to solve for A. Plus B equals 2016. And then I subtracted B and divided by 1 minus B. So I got 2016 minus B over 1 minus B. And what I noticed here is the following. The top term is 2015 greater than the bottom term all the time. Okay, because no matter what I do here, this will be 2015 more. And so the only way to make this happen, if one is 2015 more than the other, it's the same thing as saying, okay, I have 2015 plus C divided by C. This makes the top 2015 more than the bottom. These are equivalent. So consider where C is going to be, let me make sure I have this, 1 minus B. So when you put in 1 minus B for C, you get the exact same thing up here. But in this case, I can now work it out this way. I'll have 2015 over C plus C over C, which is 1. I need this to be an integer, and that will happen whenever this is an integer. And so I'm terribly running out of room, but let's see if I can shove some stuff in here. I'm going to factor 2015. I see right away, 5 goes in that. That's easy. So take out a 5. I'm left with 403. And then I was racking my brain for a little bit saying, hold on, okay, what goes in here? Well, it's not a multiple of 3, it's not a multiple of 7, not a multiple of 11, but then saw that 13 goes into that. I saw 13 times 30 is 390, so 13 times 31 will give me 403. And so every possible factor of 2015 will be some product of these. So it can either have a 5 or not have a 5, have a 13 or not have a 13, have a 31 or not have a 31, and that's the same thing as doing 2 times 2 times 2, 2 to the third, equals 8. That's the number of positive factors of this. And I'm going to end up having positive and negatives. So in this case, I have times 2, 16 possibilities that will make these cancel. And so finally, I had 87 ways to make this part 0. I have 16 ways to make this part the exact opposite of this minus here, so they would cancel. And that gives me 103 total ways to make this a real number. And as with the last one, feel free to comment with questions. I hope that this made some sense. I wish I had some more room to write. All right.